Hello friends, so in this video I'll be discussing about the light, the reflection of light, the spherical mirror and the sign convention of the spherical mirrors in this video. It is a portion of class 10. So part 1, in this part I'll be explaining mainly on the reflection of light, types of mirror which are like plane, convex and concave, and the mirror formula along with the sign convention, okay, in this particular video. So moving on straight, let us go without wasting any time. The first one comes what is light. Okay, light is a form of energy that travels in a straight line or along a straight path. Okay, then the speed of light is 3 into 10 to the power 8 meter per second. Okay, now with the help of light it helps us to see. Okay, we have this vision of seeing because of the presence of light. If there is no light, suppose if there is full darkness in our surrounding, then our eye is of no use. We cannot see anything. Okay, it's same as blind or without any eye, because without light we cannot see anything. So it helps in giving us a vision to see. Okay, now moving on, what is reflection of light? Reflection of light means it is a bouncing back of the light in the same or to the initial or same medium. Okay, that is called reflection of light. We have two laws for reflection of light. One of the law is the incident ray. Suppose this is the surface. Okay, the incident ray, the reflected ray and the normal to the point of contact, they all meet or they all lie in the same plane. As of now in 2D diagram we find it as a point. Okay, but in 3-dimensional it is a planar. Therefore they all meet in the same plane. Okay, now the another law is we normally say as a Snell's law, which says that the angle of incidence is always equal to the angle of reflection. Suppose angle I is the angle made by the incident ray with the normal, okay, normal line, and R is the angle made by the reflected ray with the normal. Then the angle of incidence, that is angle I, will be equal to angle R. That is the second law for the reflection of light, which we also call Snell's law. Okay, then we have different types of mirrors. One is plane mirror, the other one is spherical mirror. Spherical mirrors have this following. I'll be specially dealing with these two type of mirrors only, that is concave mirror and convex mirror. Okay, these are called spherical mirrors. So concave mirror are those mirror whose outer surface is polished and whose inner surface is reflecting surface. Convex mirror are those mirror whose inner surface is polished and outer surface is reflecting surface. Okay, I hope you are clear. If you are not clear, please do not forget to comment. Okay, I'll try to help you out in explaining in a better way. Okay, now in both the concave mirror and as well as in convex mirror, there are common things that are available. Okay, so in order to draw any ray diagram for both concave and convex mirror, we have this following representation designations. Okay, so the first thing is, see, suppose we can take the example of concave mirror. So concave mirror, outside is outer surface is polished, inner surface is reflecting surface. Now along the middle, in the middle, okay, there is an axis called the principal axis that passes through the center of the mirror. Okay, now the point of contact, okay, the point of contact or the intersecting point between the principal axis and the mirror is called the pole, and we denote it by P. Now since this mirror is a curve, Okay, it's a curve. If we complete a circle, there will be a center. Okay, now since it is a curve, we call it as a center of curvature. So for this curve, there will be a center. Suppose we consider the center to be here and we denote it by C, or we name it C. Okay, so this is the center of curvature. Okay, the center for the curve. Then a point between, okay, the point between the center of curvature and the pole, there is a point, we call it as principal focus. Okay, now next one, the distance from pole to principal focus F, we call it as focal length. The distance between pole to the center of curvature is called radius of curvature. Okay, and we denote it by R. Okay, radius of curvature we denote it by R, and focal length we denote it by small f. Okay, so these are the things that we have to remember. Next one, suppose an object is placed in front of the mirror. So the objects have different heights, so we just show it by one straight line perpendicular to the principal axis. Now from pole to object is called the object distance, so we denote it by u. Okay, then after drawing the ray diagram, image will be forming. Okay, for that object there will be an image formation, so the distance from the pole to that image, we call it as image distance. Okay, and we denote it by v. Clear? Now for the height of the object and height of the image, we denote it by hi. Hi means height of the image and ho means height of the object. Okay, now moving on, we have mirror formula in order to calculate the distance of the image or the nature or distance of the focal length, or maybe sometimes distance of the object. Okay, and also in order to calculate the power, not required, maybe here it's not required, but we have another formula that is called magnification. Magnification formula is also there, so as you can see here on the screen. Okay, so for mirror formula, it is 1 by v plus 1 by u equals to 1 by f. Then magnification is equal to minus v by u. It is also equal to hi by ho. Hi stands for height of the image, ho stands for height of the object. Okay, now how we derive this mirror formula and magnification, we shall deal it in the later videos. I'll be uploading about this video as well. Okay, now coming back here about the sign convention. Okay, sign convention. In sign convention, we shall study sign convention is required in order to know the nature, the position of the object and the image when we draw a ray diagram. Okay, so we have the following for concave as well as for convex mirror respectively. Now we have u, we have v, we have f, we have ho, hi. Even for convex we have u, v, f, ho and hi. Now what things will be consistent, what things will not change? Okay, let us see. Now this will be useful in numerical problems. Okay, suppose in order to know whether that particular value, maybe object distance or image distance, whether it will be negative or positive, and the nature and all, we can come to know from this sign convention. Okay, now as long as, okay, one thing just to remind you, concave mirror most of the time it will give real and inverted. Okay, the nature will be always real and inverted, and in convex the nature will be always virtual and erect. Okay, so let's go for ahead. Now u means object distance. So for U, in both the cases the object is always placed on the left side of the mirror, therefore they will be negative and negative. Okay, V will be always no, not V, another one, HO. Okay, height of the object is always placed above the principal axis, so whatever placed above the principal axis, they are taken as positive, therefore they will be always positive in both concave and convex mirror. Then let's see here. Okay, V is the image distance. Most often, as long as this nature is, okay, as long as it obeys or it remains as really inverted, the image distance of concave mirror will be negative. This will be the opposite. Okay, convex. F will also be negative and this will be the opposite. Okay, it is just the opposite of the other, provided their nature remains the same. Okay, if there is any change in their nature, okay, if it is opposite, then V and F value will be changed and even HI. Okay, so in concave, the image height of the image is formed inverted or downside the or just below the principal axis, because and moreover we can know here inverted. Okay, if it is inverted, sign will be negative. Okay, and HI here in convex mirror, since it is erect, therefore it will be positive value. Okay, now as long as the nature remains same in both concave and convex mirror, this sign convention, this sign will remain unchanged, provided U and HO for either mirror or lens, it will never change. It will remain as negative for object distance and it will always remain positive for object height of the object in any type of mirror or in any type of lens. So that is how the convention is. Now the next one, here there is one more thing, magnification. Okay, there is magnification. Now magnification is minus V by U or HI by HO. Okay, now let us see the nature. Okay, if HI is negative, it will be radially inverted. If HI is positive, it will be radially erect. Then M, if M value is equal to 1, okay, now it will be equal to 1 only when HI and HO are of the same height or V and U value are the same. So if it is 1, that means the height of the image and height of the object are same. Okay, if it is less than 1 or if it is more than 1, okay, the other case will be M can be less than 1, M can be more than 1. When M is more than 1, that means height of the object is more or height of the object is enlarged. Okay, and if M is less than 1, height of the object is I mean to say height of the image. Okay, if M is larger than 1, then height of the image will be large, okay, or enlarged. If M is less than 1, then height of the image will be small or maybe diminished, or we call it as diminished. Okay, then M can also have negative or positive value. If M equals to negative, okay, if M is negative, it will give really inverted. Okay, it will give really inverted. If M is positive value, okay, then it will be virtually erect. Okay, the nature. So that's all about the light, reflection of light, spherical mirror, sign convention, okay, and numericals and all I will be giving you in the next video. So thank you very much for watching this video. If you like it, please do not forget to subscribe, share and comment, and do not forget to click the bell icon in order to get instant notifications. If you have any doubt, difficulty, kindly do not forget to comment so that I can help you in my best possible way. Thank you very much for watching this video.